We have already seen that power series have terms which are polynomials, and polynomials from our previous experience are relatively easy to differentiate and integrate. Now, suppose we have a function that can be represented as a power series where f of x is equal to this bit here. Um, Now, that power series can be written. You can actually write the first few terms of that power series like that. So the derivative of f of x will be given by, I mean, if you find the derivative of a to the power 0, uh, it will be 0. If you find the derivative of a to x squared, it will be 2. So you can see that basically what's happening here is you're finding derivative of each term, term by term. So instead of doing that, what you can do is just go ahead. Suppose you're given that power series there. You can just go ahead and find the derivative of that power series by passing over the derivative sign into the summation sign. All right. What I mean by that is just find the derivative of the nth term. Okay. So you can just go ahead and find the derivative of the nth term. Now, what you have to know is that you can only do that over any interval contained within the interval of convergence. So you can just do this within the interval of convergence. This can only happen within the interval of convergence. In fact, for differentiation, um, an open interval is required. Okay, so you have to be really, really careful before you do that. Now, but you can notice here one thing that the derivative of a to the power 0 becomes that, the derivative of that becomes that, the derivative of that becomes that, the derivative of that. So this is what you call term by term differentiation of a power series. All right. So notice that f dash x is obtained by differentiating each term in the series for f of x. Now, term by term integration is almost similar to that. So what you can do is just go ahead and find the integral of the nth term of the series. Um, and that simplifies to that. And if you check term by term, you can see that that's actually true. All right. If you check term by term, you can see that this is what's called by, this is what's meant by term integration of a power series. So instead of going integrating term by term, you can just pass over the integral sign into the summation sign and integrate the nth term of the power series. All right. Okay, let's look at an example. So example 1, find the antiderivative of this function. This is actually a definite definite integral. Now, first of all, we have to check the interval of convergence. Now, from the previous example, the interval of convergence of this series is from negative a third to a third. Hence, the limits are within the interval of convergence. All right. Let me just write this down from previous example. From the exams that I've worked out previously, you can check some of my videos previously. I worked through, I calculated the interval of convergence of this series. So from previous example, the interval of convergence of this series is negative a third to a third. And if you look at the limits of this integral, it's from 0 to 0.1. So this is within the interval of convergence here. So hence, the limits are within the interval of convergence. Okay, so now we can go ahead and find the integral. So 0 to 0.1 of this series. Okay, so what you can do is, like I said previously, you can pass the integral sign inside the sum. So pass the integral sign inside the summation sign. Okay, you can just pass the integral into it. We have already shown why from term by term explanation for term by term integration of power series. So anyway, this will be equal to the sum from n is equals to 0 to infinity of the integral from 0 to 0.1 of this nth term. Now, again, just remember that we have some constants here. We are integrating with respect to x, which means these other guys can just be considered as constants. We can take them out. So I can simplify this to the sum from n is equals to 0 to infinity of negative 3 for n. But now, what I'm going to do is to integrate this bit. Okay? And that will give me, can actually fit it in here. All right, so that will be, and you can just use the reverse power series, okay? Because remember, we are integrating. So the reverse power series for this guy will just be x to the power n plus 1 over n plus 1. And the limits are from 0 to 0.1. All right, carry on. This will be equal to sum from n is equals to 0 to infinity. Negative 3 to power n square root of n plus 1 multiplied by, now if you plug in 0.1, that will just be 0.1 to power n plus 1 over n plus 1, which simplifies to 0.1 to power n plus 1 over n plus 1. Now here I have square root of n plus 1 multiplied by n plus 1. And you don't have to simplify it unless you